Hello, math students. Today we're going to start working on our third method for solving systems or equations. To be perfectly honest, it's my favorite way to solve systems. Graphing is great for starting because you know how to graph. It gives you a visual of what you're doing. Substitution is really nice. If you have nice problems and it's easy to solve for one variable. Elimination is more easily used in a lot of different situations. So sometimes we're calling this elimination. What we're looking for is a way to eliminate one of the variables. The problem with solving these equations is I have two equations and they each have two variables. And we don't know how to solve equations like that. However, if I could eliminate one of the variables, then I can do this. We're also going to call this the addition method. When I show you how to do these problems, I'm hoping that makes sense, but let's take a look. Here are the steps that we're going to have. Today, step one, again, is going to be taken care of for you. We're not going to have to do any multiplying at all. We are looking for opposite coefficients today. Coefficients, remember, those are just the numbers in front of variables. Opposite means same numbers but different signs. So, I'll even say today, you don't have to worry about the subtract. We are going to add our two equations together. We'll get rid of one of the variables. They'll be eliminated. That's why we call it the addition method. Once we do that, we can add those two equations together. We'll get one problem that only has one variable, so we can solve for that. And then this is like how we finished up substitution. We'll take that answer and go back into one of the original problems and be able to find the second variable. So if this is my first problem, x plus 3y equals negative 2, x minus 3y equals 16, I want you to notice that the y terms are already opposite coefficients. I've got a negative 3y on the bottom and a positive 3y on the top. That's what we're looking for. We need one of the variables to be opposite coefficients. So when I add these two equations together, remember this is really a 1x and a 1x. So we'll be able to add those two together. But I want you to really notice the y's. Positive 3y and a negative 3y. Those two would really go away. I'm not going to write 0y. I am just going to eliminate the y's. So when I do that, I end up with 2x, when I add the x's together, equals negative 2 plus 16 is 14. And then we know how to solve this. Let me get just a little bit more space here. You know that you're going to divide by 2. And when I do that, I get that x is going to be 7. Once I know the x, I have to go back into one of the two original equations. I don't care which one it is. Really doesn't matter to me. But again, I've got this all kind of worked out right here. Now that I know that the x is 7, I'm going to put the 7 into this equation. So instead of the x, you can see right here, I took this x out and I put the 7 in its place. And now, again, just one variable. I can solve this. I can subtract, and you can kind of see that already, subtract 7 from both sides. And I have 3y equals negative 9. And then again, you know how to finish this problem up. We would divide by 3. Whoops. Sorry, I just moved everything. And divide by 3. And I'm going to get that y is going to be negative 3. Once I know my x and my y, I can write my ordered pair. And that ordered pair is going to be 7, negative 3. So let's try a couple of these. I would recommend that you write these down as examples. In this problem, the y's are the opposite coefficients. Really, this is a negative 1y and a positive 1y. Notice I'm not doing a keep, change, change. You certainly can, but I'm hoping that you can see that those are both ones. One's a positive, one's a negative. When I add those y's together, they'll go away. So 2x plus 4x is 6x. And 9 plus 21 is 30. You know how to solve this. Once I know what the x is, I can find the y. It might even help if I get rid of some of my writing up here. I'm going to use the second equation. I'm going to use this one right here. I'm going to say 4 times, here's what my x was, plus y equals 21. And we can solve this. We're good at solving just regular equations. Y equals 1. So if I know the x, I know the y, I can write my ordered pair. And remember, the x has to go first. All right, in number 2. This time, it's the x's that are opposites. Remember, it doesn't matter which variable it is. It just has to be one of the two variables. So negative 5x plus 5x cancel out. 2y plus 1y is going to be 3y. And 13 plus a negative 1 is going to be 12. So y is going to be 4. Once I know what the y is, I have to go back in and find the x in one of the two equations. Personally, I kind of like the second one just because the x number, the coefficient, is already positive. So I've got 5x plus, instead of the y, I'm going to put the 4 in there. And this is just a matter of solving this regular equation. So I've got 5x equals negative 5. So when I divide, I'm going to get that x is negative 1. So negative 1, 4. Now I'm not going to do the problem that's covered up there because we don't need that kind. In this problem, this time again, the x's are the opposites. Positive 5x in the second equation, negative 5x in the top equation, cancel. 10y plus 8y is going to be 18y. Negative 25 and negative 29 will be a negative 54. So y will be negative 3. I have to find the x. I'm going to go back into either one of those top equations. It doesn't really matter. I'm going to use the second equation. You'd say 5x plus 8 times a negative 3 equals negative 29. So I would add 24. So I get 5x equals negative 5. We're running out of space. So the x is going to be negative 1. So my ordered pair, the x and then the y, the x was negative 1, the y was negative 3. This time again, the y's are the opposites. So when I add these two equations together, positive 4y and negative 4y, eliminated. 9x minus 6x is 3x. 25 minus 10 will be 15. X is 5. Once I know the x, I need the y. I'm going to use the top equation. So, oh, and I put it in the wrong spot. It's the x that I know, not the y. So it'll be 9 times 5 plus 4y is 25. So 45 plus 4y so y is going to be negative 5. Again, the ordered pair is always x and then y. So this one would be 5 and negative 5. I have 2 more problems, but I think just one more is probably going to be good enough. So actually, I'm going to choose to do this one. I don't know why I can't get that box to unclick there. There we go. When I add these two together, the y's are the opposites. So negative 2y, positive 2y, gone. Negative 1x plus 3x is going to be 2x. 12 minus 12 is 0. This problem I'm choosing to do because I have a feeling that some people might look at this and say, oh, it's a no solution. But it's not. X is just 0. Variables can be equal to 0. They can be equal to positive, negative, or 0. So if that's what the x is, let me use this second equation and say 3 times 0 plus 2y equals negative 12. 3 times 0 is just 0. And in fact, I'm not going to subtract 0 to move it. It's just not going to do anything. 2y equals negative 12. So y is going to be negative 6. So my ordered pair is 0, negative 6, which would happen to be on the y-axis. Your worksheet today has 8 problems on it. You are solving systems of equations. The answer key is in Schoology. Every problem is set to go for elimination. You add the 2 equations together, one of the variables will go away. When you're done and you've checked your work, make sure that you take the learning check in Schoology and let me know if you need any help.